Hello everyone, welcome back to the Network Fixer. Imagine this, you open Google, nothing loads, WhatsApp is down, Instagram is not refreshing, banks stop working, flights stop checking in, and the reason is not hacking, not power failure, not even server crash. The reason is one wrong BGP route. Yes, one small configuration mistake typed by one engineer in one corner of the world can break the entire internet. That is the power of BGP, Border Gateway Protocol. And that is why BGP is called the king of the internet. In this video, I will explain BGP from absolute zero. No boring theory, no CCNA style mugging. By the end of this video, you will understand what BGP really is, why the internet depends on it, why BGP causes global outages, how BGP works in real life, and how engineers troubleshoot BGP on Cisco and FortiGate. So sit back, this is not just a networking video, this is the story of how the internet survives. Let us start very simple. BGP stands for Border Gateway Protocol. Now forget the technical name. Think of BGP as Google Maps for the internet. Just like Google Map decides which road your car should take, BGP decides which path your internet traffic should take. But here is the twist. BGP does not work inside your office network. It does not care about switches or Wi-Fi. BGP works between huge networks called autonomous systems. An autonomous system, or AS, is a large network managed by one organization. For example, Google is one autonomous system, Amazon AWS is one autonomous system, Jio is one autonomous system, Airtel is one AS, Tata Communication is one AS. Each AS has its own routing policies, its own IP blocks, its own rules, and every AS gets a unique number. This number is called an ASN, or Autonomous System Number. Example, Google ASN is AS15169, Cloudflare ASN is AS number 13335. BGP is the protocol that allows these AS networks to talk to each other. Without BGP, the internet becomes thousands of isolated islands. Many people ask, why not use OSPF for the internet? It's a good question. OSPF is an interior routing protocol. It works beautifully inside offices, inside data centers, inside one organization, but OSPF was never designed for millions of routes, different companies, business policies, paid versus free traffic. OSPF mainly cares about shortest path, whereas BGP cares about policies. That is the biggest difference. The internet does not run on shortest path, it runs on business agreements, it runs on money, it runs on peering, it runs on transit, and only BGP understands that. So if you consider the business side of BGP, this is where BGP becomes more powerful. Consider ISP A may say, I will send traffic to ISP B only if I am paid. ISP C may say, I will accept traffic only for specific countries. Cloud providers may say, prefer my private backbone over public internet. BGP allows all this, OSPF cannot. Static routes cannot. That is why BGP rules the internet. You will be wondering how BGP really works. BGP does not find routes. Just repeat that. BGP does not find routes. BGP only exchanges routes. It says, "Hey neighbor, these networks are reachable through me." That is all. BGP uses TCP port number 179. It establishes a session, then it starts exchanging network prefixes, AS paths, attributes, and based on attributes, it decides the best path, not the shortest one. It always chooses the best path. If you ask me about BGP attributes, BGP decision is based on attributes. Think of attributes as filters on Amazon search. Some important attributes are weight, it's a Cisco specific, and the highest wins. The next attribute is local preference, it's inside AS and IA wins. The next preference is AS path, shorter path usually preferred. The next attribute is origin, IGP is better than EGP. The next attribute is MED, it always chooses the lower ones. BGP checks attribute in order. This order is very important. One wrong attribute and traffic goes the wrong way. Now the scary part, BGP trusts neighbors. If a neighbor says, I can reach Google, BGP believes it, even if it's a lie. This is called route hijacking. Many major outages happen because wrong route advertisement, prefix leak, missing filters. You might have heard of multiple outages because of BGP, be it Facebook outage, Google route leaks, Cloudflare incidents. All of these are BGP related. In real life, whenever the BGP fails, engineers will check BGP session state, neighbor IP reachability, ASN mismatch, route filters, advertised versus received routes. If it's on a Cisco, you can execute commands like show IP BGP summary, show IP BGP. If you're on FortiGate firewalls, you can use commands like get router info BGP summary, diagnose system BGP. Most BGP issues are not protocol problems, but configuration mistakes. Why you should learn BGP? If you understand BGP, you understand the internet, you understand cloud, you understand ISPs, you understand multi-homing. In the end, you will end up with high-paying roles. BGP is not optional anymore, it's mandatory. Now that you understand the basics, let us go deeper. Forget labs, forget diagrams, let us talk about real internet. Every time you open YouTube, your traffic does not go directly to Google. It jumps through your ISP and later goes through regional ISP. From there, it traverses through Tier 1 provider, peering exchange, Google backbone. Every single op is controlled by BGP. BGP decides which ISP to trust, which path to avoid, which route is cheaper. This is why internet speed is not just bandwidth, it is routing decisions. In the ISP, there are multiple tiers. Tier 1 ISPs are the kings. They do not pay anyone. They peer with everyone. Examples: Tata Communications, Lumen, AT&T. Tier 2 ISPs pay Tier 1, also peer with others. Tier 3 ISPs are the local ISPs. They depend fully on upstream providers. BGP keeps this entire hierarchy alive. Without BGP, ISPs would not know where to send traffic. If you are considering multi-homing and also why companies use BGP, multi-homing means one network, multiple ISPs. Why? Because one ISP can fail, one link can break, one fiber cut can isolate you. BGP allows load sharing, backup paths, ISP independence. This is why data centers, banks, cloud providers all use BGP. If you are considering the BGP path selection, let us slow down. BGP path selection is not magic. It follows several rules in order: highest weight, highest local preference, locally originated routes, shortest AS path, lowest origin type, lowest MED, eBGP over iBGP, lowest IGP cost, oldest path. If you do not understand this order, you cannot troubleshoot BGP. One missed role, traffic flows wrong. There is another concept called route filtering, which is very important in the BGP. Most internet outages happen because of no route filtering. Engineers forget to filter prefixes, limit advertisements, and the result? A small ISP advertises the entire internet and the world listens. This is called prefix leak. So, is it true that the real internet outages are caused by BGP? Let us talk in reality. Facebook outage. Facebook withdrew its own BGP routes. The internet forgot Facebook existed. Google route leak. A small ISP announced Google routes. Traffic went the wrong way. If you are considering the Cloudflare incidents, there are chances of improper BGP filtering and later on massive traffic misdirection. BGP did exactly what it was told and humans failed. In real-time environment, you should be knowing how to configure BGP and also how to troubleshoot the BGP issues. There are two types of BGP here. They are eBGP and iBGP. eBGP is between different ASN numbers. It's used on the internet. iBGP is used inside the same ASN. It's used in large enterprises. Key rule: iBGP does not forward routes learned from another iBGP neighbor. This rule alone breaks many networks. Regardless of whichever device you choose, be it from Cisco, FortiGate, Palo Alto, or any other vendor for that matter, BGP always needs ASN number, neighbor IP, neighbor ASN, networks to advertise. Miss one and BGP fails silently. If you are trying to troubleshoot BGP, please do not panic. Always try to check in order: physical link, IP reachability, BGP session stage, prefix exchange, attribute manipulation. 90% issues are layer 3, not BGP itself. There are a few troubleshooting commands which can be used in Cisco devices. Show IP BGP summary, show IP BGP neighbors, show IP route BGP, look for idle state, active state, missing prefixes. If you are from a FortiGate background, there are a few troubleshooting commands that you can use for troubleshooting BGP. They are get router info BGP summary, get router info BGP neighbors, diag sys BGP. FortiGate logs are very descriptive. Read them. So you might be thinking how to prevent BGP disasters. Always check prefix filters, route limits, max prefix, AS path filters. Never trust blindly. BGP trusts. Engineer must verify. So what's the career impact of BGP? If you master BGP, you qualify for ISP roles, cloud networking, network architect, high-paying contracts. BGP is not optional, it is elite networking. There are many historical events of BGP outages. Facebook 2021 BGP outage, Pakistan YouTube BGP hijack, Google BGP route leak, Cloudflare BGP leak, Level 3 or CenturyLink outage. You might have heard in the news headlines how Facebook erased itself from the internet, one ISP hijacked YouTube, one route leak broke the entire Google traffic. All of these issues were caused by BGP. What is a BGP route leak? A BGP route leak happens when a network advertises routes it should not advertise. And that's it. No hacking needed, no malware, no attack, just wrong BGP behavior. Think of BGP like this. Imagine you run a small bus service. You are allowed to say, I can take passengers to my town only, but instead you accidentally announce, I can take passengers to every city in the country. Now, big bus companies send traffic to you. You don't have capacity. Everything jams. Cities become unreachable. That is BGP route leak. How a small ISP can hijack global traffic. This sounds scary because it is a small ISP. That is what it connects to, a big ISP using BGP. They receive full internet routes. By mistake, they re-advertise those routes. Bigger ISPs believe them. Traffic flows through the small ISP. The small ISP collapses under load, and the result is packet loss, latency, global outage, no malicious intent, just missing filters. Why this is the most feared BGP failure? Because BGP trusts neighbors, no authentication by default, one mistake propagates globally, damage spreads in minutes. Engineers fear route leaks more than device failure, fiber cuts, power outages, because those are local, route leaks are global. If there is any missing prefix filters, you might be wondering what should happen. An ISP should say, I will accept only these IP ranges from you. But what actually happens? No filters are applied, so the router says, sure, I will accept everything. And the result is, customer advertises full internet, ISP propagates it, internet in chaos, and end of the day, you don't have any control on the BGP. Why Tier 1 ISPs make these mistakes? Tier 1 ISPs are run by humans. Mistakes happen due to automation scripts, emergency changes, vendor bugs, poor validation, time pressure. BGP is powerful but unforgiving. If you go back to the history, you might have heard the famous route leak example, which was the Pakistan YouTube issue. Pakistan ISP advertised YouTube routes, global traffic flowed there, YouTube disappeared worldwide. This was a classic route leak example. So how engineers prevent route leaks? Every professional ISP must use prefix filters, AS path filters, max prefix limits, route maps, RPKI or BGP validation, no exceptions. If you are working as a network engineer and you are aware of BGP issues, flapping and instability are the most common issues that we see on a day-to-day basis. BGP flapping is one of the most common and most frustrating problems in real ISP networks. When BGP flaps, routes keep coming and going. The internet works, then it doesn't, then it works again. Users describe it as internet going up and down. This usually happens because of unstable links, timer mismatch, or aggressive route dampening. When routes flap too often, BGP starts suppressing them. The intention is stability, but the result is silence. Traffic has nowhere to go. BGP flapping doesn't always cause a full outage, but it creates an unreliable network, and unreliable networks lose trust. When it comes to real-world BGP troubleshooting, instead of asking, what does the book say, we ask a better question. If I were the ISP engineer, what would I do right now? BGP might be stuck in active state, routes may be received but never installed. Traffic may go out one path and come back another, causing asymmetric routing. In these moments, panic makes things worse. A calm troubleshooting mindset is what separates engineers from button clickers. Moreover, not every outage needs drama. Sometimes the most powerful content is calm, consistent analysis. A weekly BGP health report answers one question: how healthy is the global internet right now? We look at major route leaks, prefix withdrawals, ISP level incidents, then we explain them simply: no noise, no panic, just clarity. How to prevent BGP outages? Most BGP outages are preventable. They don't happen because BGP is broken, they happen because safeguards are missing. Professional networks always use prefix filtering, max prefix limits, AS path validation, IRR and RPKI checks. These controls don't slow BGP down, they protect it. Prevention doesn't make headlines, but it saves careers. I would like to reiterate, if you understand BGP, you understand the internet. And if you understand the internet, you are the king of networking. If you understood this outage, you are already ahead of most network engineers, because this was not about commands, it was not about devices, it was about BGP decisions. And remember this, BGP did not fail, BGP did exactly what it was told. If you want to truly understand how the internet breaks and how professionals fix it, here we don't panic during outages, We analyzed them. BGP didn't break the internet, a wrong decision did. Subscribe to the Network Fixer to understand the internet before it breaks again. Thank you for watching. Until the next video, take care of yourself and have a great day. Bye bye.